welcome back to Amplified 208. Today we have ourselves an Onkyo M5060R Integra. This amplifier here, I did a complete recap on it. Straightened all the chassis. This thing was dropped at one time. The previous owner, the guy that owns this now, he wanted it recapped and put all new LEDs in the front. You want a nice green glow. A lot of the indicator lamps here, power light and everything did work, but the speakers on and off 1 and 2 didn't work, and the indicator for on and off, that's on. Chassis was really bent. Meters, a lot of lights didn't work. I'll probably do a little bit of a montage with part of the video. I hope you guys kind of stick through the montage of it, and then I'll come back. Now listen to this switch here. It's a volume pot. Definitely needs some cleaning and lubrication. I'll do that. Take a video after. You guys have seen all the other parts of the video and check that stuff out. And so now we're at the stage where I'm going to start playing some music through it. I got the P3060R. P3060R. It's been recapped. It's been completely recapped. All with capacitors, Nichicon, all very high end, 105 degrees C, 10,000 hour capacitors. We don't mess around. All very low ESR. Every single capacitor was taken out, measured, and compared to the new capacitor being put in. If the new capacitor was hopefully lower, and it worked out very well. Okay, so which was a good thing, because these capacitors right from Onkyo on these 3060Rs were very well matched. I was very surprised. But the old capacitors I took out of here. Yeah, well, you can see here's a bag. I'll take pictures of it and show it in the video maybe later on, but if not, but yeah, these are just, that was just the amp, and then there's the preamp, and oh yeah, there's quite a few capacitors, but not too many, because a lot of these Onkyo, the 3060Rs and the Onkyo, the 5060R completely recapped, all LED converted, which you guys seen in the previous video, and you've seen the video that that came with it. I hope that you watched kind of the montage between now. I also added, as you can tell, there's a blue glow in the back, and you'd maybe wondering why that is. Well, this thing now has a automatic on-off temperature control running off a MOSFET, 12 volt power supply on the internal side of it, and it runs, and it takes about, I don't know, about 8.5 minutes. I timed it on a stopwatch. You power this thing up from being at room temperature, 8.5 minutes later, then all of a sudden, boom, you see blue lights glowing in the back. Oh, what's that? Oh, that's the automatic fan controls. And there's two huge fans at the back. The computer-sized fans. You may be able to hear them running. I'll be real quiet. Oh yeah, sounds very good. One on the left side of the transformer that goes down underneath, and one on the right side. You may be wondering why I ask if I put them on there. Well, the reason I put them on there is because this owner is more than likely gonna have something very close to the top of this amplifier. And if anybody knows Onkyos, they run very hot. As you can see right now, I have a 1/4 inch gap, maybe a 1/4 inch gap between these feet on this preamp compared to the amplifier. And with that being that way, you don't have a whole lot of airspace in between there. This gentleman here, I think, who owns this unit, he's going to be running it with maybe, I tested it with, you know, about 1.5 inch gap, and now I'm testing it with the 1/4 inch gap. But those fans in the back, they're from a PC style fan. And I'll show a quick example here. It's one of these, the SICK Flows 120s, 120 millimeter fans. It's got two of these on the back side where the transformer ventilation goes in, 2000 RPM. And it's got a MOSFET control. And then when it's at operating temperature, it doesn't come on until it's at operating temperature. And then it will drop down, the MOSFET will drop down to about, I don't know, it puts 11 volts at those fans, 11.5 volts. So the MOSFET's only dropping about 500 millivolts, which is pretty good. And it's got its own heat sink in there with a 12 volt 3 amp power supply with a heat sink on it. The MOSFET's able to dissipate about 27 watts because it is a plastic package, but it is thermal pasted to a heat sink, strapped to a standalone 12 volt power supply, which is like one of those modular units that I wired in through the switch, and it works very well. As you can see, here's the specs for those fans, and it's got two of them on there, and it uses existing screw holes in the back of the chassis. You put two screws in it and a little bit of a 2-way adhesive on the corner just to stop it from rattling. And that way, if you ever want to, you can just completely take them off, unsolder two connections, and the whole fan circuit will come right out of there. The NTC comes up in between into the heat sink and monitors the temperature, and then as soon as it gets to a happy spot, it'll just turn on full power. As you see, it's blue in the back and green in the front. I converted this light here, LED, that's incandescent, that's incandescent. This one's LED, but that's, you switch it over there. It's yellow as well because the incandescent burnout, but these here are very fragile on the inside of this amplifier. Anyway, if I can show you, if anybody knows, with these incandescent lights on the back, those little rubber mounts and stuff like that, they'll get so hard they're like almost like glass. So the second you touch them, they just break from the heat of these incandescent bulbs. I'm going to turn that back to tape because that's where the input. I'm going to start bumping this thing with the music, man. This thing sounds nice. And preamp, I cleaned the volume controls. I'll show some. The pictures I had for the volume control when I cleaned it under the microscope. I lost them, but I did take apart the volume control. These are Alpine or Alp or whatever style potentiometers. Very nice, but this one here does have a deviation between the left and the right carbon track that's on them. It's not a stepped attenuator, so it is a carbon track pot. One's about 155-ish, and the other one's about 151-ish. It's 150-ish, so there is about a 3K. It's about roughly 3K difference between the left and the right. So there is a bit of a variation, but that's normal. This thing's older than I am, so what can you expect? The balance control pot, cleaned it right up, very good. It worked out. They were matched left and right very nicely. The treble pot was good. It was good condition. As you can see, it's the Alp style pot, but it's only got like a couple of gangs to it. But the bass pot, now that thing's a pain in the ass. That bitch gave me a lot of trouble to try to get the noise out of the pot, because I'll throw some pictures up on the side of the screen here, but you got to make sure how you put these things together, that you make sure you don't mess with the clock timing on any of these, especially this one, because you can reverse it 180 degrees. And not only that, you can put the 150K, the 50K, the 150K, and the 50K. If you mix those up and with any of those, you'll mess everything all up. Believe me. So make sure when you take these pots apart, and they have that little locking clip in the back, and they're a pain to get off without snapping them in half. Believe me, especially when all the plastics are older than I am. This thing's like yeah, this is an old this is 78-ish. Yeah, it's in the 70s. It's back then. Late 70s, maybe early 80s, late 70s. I can't remember exactly. I have to look at the schematic. But yeah, it's old when you do this. Anyway, so what I'm going to do, yeah, I'll throw this in this video too. I'm not even going to mess around. This is how you would properly check the bias and the offset, the VCT, and the servo circuits. Okay. Because there's a servo circuits up here. You got your voltage center tap here, which is this circuit here. Let me get my bearings here. We'll zoom in, and VCT, that's the circuit here. And then what you're gonna do in order to set these is you're gonna want to go to this side of the diode of 203 and 201 and 203, and you're gonna want to measure with your digital voltmeter from ground to these 2 points, and you're gonna want to make sure this is center. And you're gonna want to measure your DC voltage, 15 volts here and 15 volts here, and try to get these matched as close as you can possibly can. Either use 2 voltmeters from ground to here in order to measure it, to center this point out. And then you go down. I'll show you where these 2 points are there. 201 and 203. Alright, if we can see it on the camera. Just give me 1 second. I'll locate it again. 201 and 203. And where I picked off the signal, bring you back over. I hope it don't make you sick for moving around. I went to the resistors. I went to R22 and R219 is where I did. And you measure at the backside because it's going to be the exact same point on the circuit. And then what you want to do is make sure when you measure your voltages in a circuit that where you measure your voltages that you're not going to short something out. Okay. So there's 218. It's 219. So 219. I'll get a little pointer here. Oops. 219. Let me get the camera here so you can actually see it. 219 is right here. So if you measure at this point here and then adjust this pot, and there's a resistor on the other side of that, right there, on this receiver. So there's one here, get focused, one here, and there's one on the other side. And that's these two resistors right here. And this is for the same for the left and right channel. And when you measure there, you're going to get the same here on those sides because it's all connected. You're going to get 15 volts and you're going to get 15 volts. So this section is going to be set after you get that. And then the other side of the MOSFET, or BJT pack here, it's all one transistor. And then you'll get 5.1, 5.1, but this is inside of a plastic case on the inside, this section right here. These are on the external side of it. Sorry for making you sick, but see, it's all on the inside of this case. Right here, that's this section right from about here down. Don't really show it. It's about here down. It's all this stuff inside here. You get your diff pairs down here and your constant current source diff pairs, and then yeah, so it's all in there. So that's how you set the offset for that. All right, so now we're going to go down to the servo circuit. Now in the servo circuit, you want to come to your resistor 303, and it'll be like 403 or something for the right side, but this is what it is, 403. And you're gonna make the base right here 0 volts. Here at this test point, I'll show you where the test point is. Test point is right there, and you're gonna read, when you stick your meter on there, you're gonna read about 100 millivolts. And then on this side, you're going to read about between 100 and 0 millivolts. So this side here, these are op amp outputs, which is normal. And then you got your output stage here. Those are your emitter resistors here. Those two. And the same with these two. This is kind of like your equalization. This is your equalization amplifier right here. And on this side is your output amplifier. So bring that light up. Maybe I'll turn some more light on here once. There we go. Might help, might have a lot of glare. Okay. Alright. But anyway, yes. And then, okay, so anybody that, if you're working with servo circuits, like I said, so that you want to measure across here and get your 15 volts, focus, 15 volts here and there. Make sure that's centered. And then when you do that, it's going to allow the op amp a little better reference on the differential pair, which is down here, down in here. Okay, so that's where I said where if you measured on test point 1 and test point 1 on the left and right, right here, you're going to measure your 100 millivolts at this point, which is going to be fine. But if you measure on pin 2 of the op amp, you're going to have 0 volts, and you're going to have 0 volts here, which goes out to this pot. So that's why you want to measure the difference from ground to here. You want to be active at 0, because then pin 3 is 0, and then the op amp's going to want to make pin 2 0, which makes it's going to want to offset for the rest of the circuit. All right, because it's a servo circuit. It's always going to want to try to make the output or the inputs match. The output's going to make the the output is going to want to make both pins 2 and 3 of the inputs, plus and minus, the same voltage. That's how the op amps work. That's all the switching. Okay, one second. Let me get this here, and I'll show you. couple other spots for the servo circuit for the output amplifier. Okay. Output amp is over. And that's a transient input amplifier right here. Alright. This circuit here. So basically, if you measure from your ground with your digital multimeter onto your output amplifier here, at this point, just like any class AB amplifier, this is your output amplifier stage. And as you're going through from your equalization amplifier, which would be your phono amplifier stage, and then in your other stage, and you look at the block diagram, I'll kind of go through it in a minute, but then it goes out to your output amplifier. If you measure here and you have a DC offset, which you probably have a hard time doing because this op amp is going to try to accommodate for that. It's gonna make this point center. It's going to want to try to pull it through the rail. So this is your plus and minus, I think it was 22 volts or something here. I think it's on this one, 22, 30 volts. So plus and minus 32 volts here, or whatever it does, it's probably like 20. I don't think it's quite that high, but it'll bump it up a lot. I'd have to look at it. It's hard to examine when you're doing it on video. I like to be exactly. It's OCD. Okay, so anyway, there's your 32 volts, right? And I measured 33, so there you go. So there's 33 there, negative 33 here, negative 31 there. Goes into your bases, your push-pull stage. This is your bias network. It's your 1.7, your negative 1.2. It keeps these in the active region, and they're going to push it out to your stage. Right here, see, as you can indicate by the arrow. Okay, let me zoom this out a little bit. Okay. And then it goes out through. There we go. That's a power supply stage. Out through here, and then there's your output that goes to your amplifier, which goes up. And then there's your signal for your servo, and that's a whole new ball game. I don't think I'll get into that in a moment. But you really don't need the servo circuits for these Onkyos. And you should use them, but you just got to be careful. Whatever you put into these amplifiers, if it has a DC offset, it's going to be almost amplified at the output until the op amp circuit. Right here, the servo amplifiers have time to react to it. They're pretty fast, but they can put DC on your speakers, so they got to be careful. And the amp will clip out real quick if it recognizes the DC on the output. It will clips out very quickly, and I know that because these preamp, as soon as you get scratchy controls on these preamps, you will go like this. Oh yeah, see, if you do that with a cell phone input like this one, where they're not decoupled with a capacitor, they will cause that to happen. You put it on a DVD player, you can sit there and go like this back and forth with that pot, and it won't even move the meters. You see how that moves the meters? You put a DVD player on it, CD player, tape deck, anything that's decoupled from a DC offset, you will not have that. This is not decoupled from a DC offset for some reason. I don't know, it's fucked. But it will do that. You put it on a DVD player like this one, you won't have that issue. You put it on a tuner, you won't have the issue. You put it on a tape deck, you won't have the issue. This, for that phone, you hook it up with the 3.55 to the Type C, 355 to the RCA, you will have the issue. Okay. And the servo circuit on this side, to adjust it, you measure your pins from 2 and 3, and then your output, and you take this circuit here on this pot, and what I did is I went to resistor, let me see here, 545. So I went to this resistor here, 545, and this is for the, I'm pretty sure it's the left side or the right side. It's left side. Right side's the same, just a different number. But you come here, and I went to this point on D513, and all I did was measure for 0 volts on pin 6. But I measured it here on the back of the resistor. I didn't measure here at the op amp in case I could slip off, because you don't want to be measuring these op amps with your probe or whatever and I'll accidentally skip off. This is wood, by the way.
skip off with a piece of metal because you'll end up bucking her all up. So there's 554 right here, that resistor. And if you see it, the trace, then it indicates it going to that pin 3. And you want to measure there with your probe. Measure there, up against it and away from the op amp. So if you slip, you're just going to kind of go up. And then if you hit it there, you'll get a good connection, and then you'll be able to sit there and adjust this pot for this point right here to be exactly 0 volts. And when this is 0 volts, this op amp's going to make everything else up to here. This is kind of, think of this as an amplifier. This is your input differential stage, and then you're getting into here, your bias kind of a network, and then you get to here, there's your output state, push pull, here's your emitter resistors here. You know what I mean? Like the bias and everything, and it's all like this is for your DC offset stage, and this is for your bias, and this is your emitter resistor, your compensation miller, I think what that's for. Close enough. But yeah, you get the point. And these are little push. So you'll measure right here with your probe. There's like your amplifier's DC offset 0 point, because these are complete coupled. There's no offset on them. Okay, so there you go. Anyway, if you have any questions or whatever, I could go into more depth if you want on how to set the servo circuits and where to measure in a different video. But right now I think I've talked long enough, and I'll put on some music. I have the input signal on this scope up here, and I have the output signal coming from the amplifier down here, top, left, right channels, into a set of SK101s. And we'll put some copyright-free music on, and we'll listen to a song, and then we'll call her a done deal on this Onkyo. This thing has been hours in the making. A lot of work has went into this thing, that's for sure. Alright, here we go.
What's left? The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the highways, and on we'll go. We'll go through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go through the wastelands, through the highways, and on we'll go. Fueled by them to see the horizon, turn us to thousands, and we'll grow in number. Fueled by them to see the horizon, turn us to thousands.
Well, I just want to say thanks for watching. If you have any questions about
How to set the servo circuits on here and the VCT offsets, comment, question. Unless you're, yeah, I'll let you know. But other than that, thanks for watching. I appreciate it, and I'll bring you into the next one. Alright, thanks for watching.